Hi, I'm Alex Reeves. I work at Data Skeptic as a data guy that wears a lot of hats, data scientist sometimes, data engineer other times, just whatever the situation calls for. I got my PhD in neuroscience from UCLA at the end of 2016 and knew that I wanted to dive into data science right after that. The story of how I got in touch with you, Kyle, right after I got my PhD, I did work as a postdoc, which is like what you do in academia after your PhD. And it was basically just finishing some projects that I began during my PhD. Meanwhile, looking to get into data science, the industry side of things, out of academia and into industry side.
There are many listeners, either currently in grad school or in a postdoc role like you were, who are thinking about the same transition. Do you have any thoughts about what they should know going into that they might not know now?
Oh, yeah. So, first, I think you just have to have some confidence in your abilities. It can be a little nerve wracking to jump from academia into data science because you're not sure how your skill set translates directly into data science. That's how I felt, but I just kept telling myself, I figured out a lot of very difficult concepts during my PhD. I think that skill set in itself is, a testament to my ability to learn things. And so if I just keep at it, things should work out. And so I just had faith that they would. Yeah, like practically speaking, what really helped was things like translating my skill set into data science related skills. Taking my CV, my curriculum vitae, I'm not sure the pronunciation on that, and turning it into a resume that's relevant for data science was a good exercise in kind of identifying what I had and what I didn't have going forward. Taking the parts that I didn't have, so like I didn't have a lot of experience using GitHub and making commits on repositories. So I started building a portfolio of projects on GitHub where I could demonstrate my ability to work with repos and to also demonstrate programming ability, because I knew that was something that is hard to convey in a resume. And so I made an effort to have some projects that people could view on my GitHub to give them confidence that I was capable as a programmer. And I made sure the projects were not your standard Titanic. Like if you go on Kaggle, the data science competitions website, the first tutorial they have you go through is the Titanic data set and do an exploratory data analysis. But that's been done so many times, I made sure I didn't do a project like that. I did something a little more custom. Like one of them was like to extract all the relationships between ingredients in a cookbook thing and show the network of which ingredients go best with each other. I did another one where I pulled a bunch of Reddit comments and figured out which ones had been removed by moderators and which hadn't, and turned it into a text classification project where I predicted whether a future comment would be removed. And so those were custom enough where I felt like I had to do some thinking about data problems. And so I was, proud to put that on the GitHub and felt like that could show my abilities to be creative and to program.
One interesting thing about your NLP project that you were just mentioning is it was in what we might call the BB, the before BERT days,
Yeah.
which you've obviously gotten some exposure to. Can you maybe talk a little bit about how you approached the problem before such a tool was available, and maybe how innovative that was to the type of work that you've been doing?
What I was doing at that point was just reading through a lot of what people had done in similar text classification competitions on Kaggle. And what that amounted to was constructing word frequencies vectors, like constructing TF-IDFs for, let's say, like a limited subset of 3,000 unique words in a data set, and then using various algorithms on the TF-IDF vectors to construct classifiers for many, many documents. Let's say like each Reddit comment is a document or a row in this data set, and the Reddit comment has associated with it a relative frequency for each word in the vocabulary we're considering, like a 3,000 word vocabulary we're considering. And yeah. So it's changed since BERT, though. Yeah.
So we're going to talk about one of the big projects you've delivered in the last year. To kick things off, maybe can you give a summary of what we were trying to accomplish and sort of the high level of what we built?
I think we're talking about the serverless machine learning pipeline that we built for the chatbot that we're working on, right? I think we started talking about it back in May. And it all began with the excitement over the BERT language model because it could just generate these great feature vectors automatically. The BERT language model could generate these fixed length vectors that had a lot of great features just embedded inside of them. And it was kind of like domain agnostic to these vectors. Like it was really exciting to think about possibilities because it could handle so many different kinds of text.
Yeah, so it's interesting to kind of make a comparison there between the BERT vector values and the TF-IDF frequency vector you had before.
It's like the TF-IDFs are kind of looking at single words at a time, whereas the BERT embeddings are considering, the context of the words, not just what word is in the sentence, but what other words are around that word in the sentence. And so that added layer of complexity is a much closer approximation, I feel like, to the way that we use language, right? There's more, I don't know if you call it understanding, but it's got more of an understanding component to the embedding than a TF-IDF, where it's just kind of counting up the words in a sentence.
Yeah, you made a really interesting point that we're kind of trading off interpretability for complexity. That the TF-IDF vectors, you could look at them and you know exactly how they were calculated and how to a certain degree, interpret them. Actually, to a fairly good degree, I would say. Whereas the BERT vectors, it's like, oh, these are just magic numbers that I trust because they work really well.
Yeah.
So naturally, that model has to perform better. Otherwise, why would we take the trade-off? What are your thoughts on the approach to that trade-off? Like, how much improvement did we see? I know we didn't do a strict A/B test in this project, but roughly speaking, since you've worked in both worlds, what sort of user experience, someone interacting with a model, how much improvement would you notice between maybe a TF-IDF vector-based approach and a BERT-based approach?
I mean, there are a lot of factors to consider about like how to make the comparison completely fair. But if I'm just kind of going off of what the experience was like what you said, what the experience was, the bird-based approach took much less effort. Like there was no real grid searching happening. It was just kind of the default settings for an XGBoost algorithm. Oh, so I should mention the comparison that I did was take an approach, a TF-IDF plus XGBoost approach to the Reddit comment data set where I'm trying to predict whether the Reddit comment was going to be removed or not. Similarly, take BERT vectors generated from the Reddit comments and then constructing an XGBoost model that uses the BERT vectors to classify or infer whether a Reddit comment would be removed. So the difference between constructing all the TF-IDF vectors and considering the different feature engineering approaches, like how to handle like white space and formatting characters, that took a lot of time with the TF-IDF stuff. The BERT-based approach basically took very almost no consideration on my part other than to generate the vectors and load them into the XGBoost algorithm. It took much less time to get a very similar result. In the end, I think the AUCs were both around zero point 0.8, and it took significant effort on my part to get the TF-IDFs up to that, whereas with BERT, it was basically first time.
Let's talk through then the core implementation before maybe the serverless components, just using BERT. I know we've been talking about it a lot on the show, but I'm sure not all listeners have gone and tried it out. If today's the day for somebody, what do they need to do? Where do they go? What do they do in Jupyter Notebook? And what can they expect?
I thought a very smooth introduction to using BERT was the BERT as a service repo. The README for that is just excellent in terms of getting you set up. What the repo does is it just creates a server client arrangement that uses TensorFlow serving in the background, I think, to serve inferences from the BERT model. You download, clone the repo, and you download a copy of the BERT language model from Google and follow the instructions on the repo. And within 30 minutes, you'll be serving BERT vectors from sample sentences. It's just a matter of figuring out how to transform text that you have in like if you've got a CSV of text records and some label that you want to apply to them, you can throw text records in, 200 at a time into this BERT as a service and get back chunks and build up a data set of BERT vectors that way. And then you've got your CSV of BERT vectors and labels, and you can run a classifier algorithm on that data set. So it's not too bad if you use that BERT as a service repo.
And the Google language model, I think there's two versions. Can you talk a little bit about the motivation for which one to use and how that affects the development process?
I elected to try to get this all working on my local machine just because I was at that stage in my development of technical skills. And so that meant using the regular size BERT model, not the large BERT model. Even with just the regular BERT model, I think that took about 4 gigs, 6 gigs of memory, maybe even 8 gigs. And then I couldn't even load the large BERT model into memory. So I think I would have needed GPU for that. And that means setting up, for example, like an EC2 with a GPU in AWS, which we might experiment with that. But at the time,
So we, through all this kind of research you were doing, uncovered that BERT was a great tool for some of our use cases, in particular for what is essentially a custom use case or more of an on-demand use case. Contrary to a lot of machine learning problems, we didn't necessarily know our data set to begin with, but we wanted to bring the power of machine learning to the table.
I think this is where the serverless part of the machine learning pipeline comes in, right? So the first part of the pipeline was to just be able to take a data set that we're interested in and convert it into a text data set and then convert it into BERT vectors and then get a model from that. But then to do it serverlessly so that we can let lots of people do the same thing, we did it with AWS serverless components.
Yeah, so I think that's an interesting point about where we've gotten so far that we knew we wanted to kind of, in a certain way, democratize machine learning, allow people to train their own intents. So it's really neat that we can kind of allow those people to train up some models without too much machine learning background. What do they really need to know if they want to use this tool?
I think they need to know a little bit about what constitutes a good data set. So if they can put together a CSV where they've got two columns, one column is a column of text, and then the other column is the label. If they can do that much, construct a data set that looks like that, starting with a couple hundred would be good. More data is better, depending on how many different labels. If they do that much, that's probably enough to get a model out of the system.
So historically, I don't know that there's a hard and fast rule of this, but a lot of rules of thumb and heuristics. Not too many years ago, people would say to do any NLP problem that's non-trivial, you needed about 100,000 examples. How come you're saying we only need 100 now?
Oh, yeah. That's the power of transfer learning. We've got extremely powerful BERT language model that does a lot of the legwork in terms of just generally understanding how the intents work and what's the key features that differentiate different pieces of text. So, because we generate great features automatically using BERT, the data sets can be smaller.
Thanks to this week's sponsor, Brilliant.org. I assume most of you are already on it, checking out the problem of the day and stuff like that. So today, think about the people in your life who might not yet be on Brilliant.org. And do yourself a favor, knock someone special right off your holiday to-do list. Give the gift of Brilliant by visiting brilliant.org/dataskeptic. Give the gift of a Brilliant premium subscription. For me personally, this would have topped any gift I ever got around the holidays. Brilliant is a fun way to nurture curiosity, build confidence, and develop problem-solving skills. Brilliant's thought-provoking content breaks up complexities into bite-sized, understandable chunks that will lead you from curiosity to mastery. So head over to brilliant.org/dataskeptic. Help spark a lifelong love of learning at brilliant.org/dataskeptic. So you took on this challenge of putting together a essentially no code tool to build machine learning models where people can provide some formatted file like the CSV with the two columns and here are all my examples and essentially hit a button and say go. Let's get into the implementation of that. While the user might not have to worry too much about it, algorithmically, what's happening under the hood?
Say that they have the CSV and say it's located here, then we run a series of checks to make sure that, okay, did they say where the object is located? Do we have access to it? Just basic checks like that. And if all that checks out, we begin this batch job generating BERT vectors for each row. We're expecting like each row to have a text column and a label column. We transform the text column into BERT vectors row by row. And as the rows get transformed, once it's fully transformed, throw that into an XGBoost algorithm. It could be another algorithm, but XGBoost has given us great results so far. We do like fivefold cross validation. Once that model is built, we pickle it and put it into S3 subdirectory that we can retrieve for them later when they want to actually use the model.
The training pipeline sounds like it begins with the drop of the CSV, and then there's some, updates, and at the end of it, out pops a nice machine learning model. What does that model then take as input, and what are its labels?
When they want to use the model, we'll load it into either like a Lambda function or into an instance within a ECS cluster and let them make inferences from the model. And what they're going to give us are snippets of text. And then we'll have a way of transforming that text into BERT vectors kind of in an online fashion and pass those online transformations of BERT vectors into the pickled text classifier model that we built for them. Out generates a label based on the labels that were given to us in the original CSV of what it infers that piece of text should be labeled as.
So one of the challenges you had was that this had to be a general purpose tool. You didn't know the intents in advance or anything like that. That works well, obviously, for anyone to do this kind of no code, real time training. What are some of the ideas you're thinking about if we want to provide a little bit more complexity and customization? What are some of the levers and knobs that you might want to pull if you were trying to train a more specialized model for yourself?
A popular approach for improving the performance of a data set is to augment the data set. Like with image classification, it's a common approach to increase the size of a data set almost artificially is to, do like shearing transformations to the images in a data set. That just means like stretching the images and kind of warping the images. What you could do similarly would be to take a model like GP2, like a generative model, where it doesn't give back vectors like numbers, it gives back text. It's kind of a reply to your text. And you could augment your data set with the replies from like a generative model like GPT-2 so that you have more instances of each kind of class for your labels. That could kind of automatically improve the performance of your classifier model.
Yeah, very interesting idea. The other thing I want you to keep thinking about, we'll probably have you back on the show when you figured it out, is how can we make this even easier by taking away the need to provide the intents?
Mm, yeah, that's interesting. Like some kind of clustering approach.
Exactly, yeah.
Yeah.
Let's talk a little bit now about the implementation. I think anyone who is familiar with machine learning in any hands-on way whatsoever knows how to do a fit and then use a predict method. Let's start from there. What are the technology and implementation steps?
Getting out of Jupyter notebooks, I would say, is the first step, and running Python scripts instead of running it out of a Jupyter notebook. That goes a long way towards reproducibility. And then the next step for reproducibility, after you've got a bunch of Python scripts that can do what you need to do in terms of generating BERT vectors or a classifier model, is to get that working inside of a Docker container. Super important to get things running inside of a Docker container because that means you can expect to run that same process in the cloud in a reproducible way or on other people's machines too. So once you've got a Docker container that can run the same machine learning pipeline that you're running in your Jupyter notebook, you've won half the battle, in my opinion. And the last half of the battle is being able to spin up that process on demand in the cloud. And for us, it was using AWS Batch as the container orchestrator for figuring out how to manage all the requests for running that Docker container that you built with your machine learning pipeline inside of it.
So AWS Batch it's been around for a little bit, but it's a relatively new and not super widely known tool. Can you describe what that is?
Yeah, so AWS Batch, the way I think about it, it's basically a serverless system for, like in our case, for building a model, but it could be for all kinds of Docker processes. Taking a bunch of requests, managing that request inside of a queue, and then going through that queue of requests to assemble the compute resources that you need for running that Docker container. Like for BERT, you need a bunch of RAM to load the model into memory. It can take a little bit of time to assemble those compute resources, but Amazon does that for you. You don't have to worry about managing that. Once it's assembled the compute resources, it loads your Docker container that has your machine learning pipeline process inside of it and runs it. Inside that process, we're loading the result of the model building process, the pickled model, into S3 so that we have kind of the results of the modeling. Oh, and also we're writing to a DynamoDB record throughout the whole process so that if something goes wrong, we know what happened. And when things go right, we can report key metrics about the model inside of the DynamoDB. And just to summarize, AWS Batch is basically a service for spinning up EC2 instances, running a Docker container inside them, and spinning them back down.
So that's a little weird in a sense. I mean, EC2 is a server. Why do we get to call this a serverless process?
Yeah, no, that's a good point. I don't want to say it's a misnomer, this whole serverless word, but it doesn't mean there's no server. At the end of the day, when you first hear the word, it could be confusing. Kind of like how we use the term wireless almost. It's like there are servers, you just don't have to worry about managing them. At the end of the day, there's a machine in a compute centers. What are they called? Yeah,
Data
your
center?
code is running on a machine inside there. So there's a server. It's just serverless in the sense that you don't have to think about provisioning or managing that server.
And why was AWS Batch an interesting choice for you in this project?
It's able to assemble larger compute resources compared to something like AWS Lambda. And Lambda is like the poster child of the whole serverless movement. There, you're running functions as a service, but it's got these memory and time execution limits that make it ill suited for machine learning model building processes because those processes can take a while, especially when you're dealing with these huge language models that we use for transfer learning. The memory limits become an issue quickly. We needed big compute resources to take advantage of these huge language models. And Batch is the offering from AWS that lets you request things like 2 virtual CPUs and 10 gigs of RAM. That's why we went the batch route versus trying to do it all with lambdas. So AWS Batch give you access to tons of compute if you need it. Like if lots and lots of people, if there's a burst of activity of interest in using this machine learning pipeline service, then AWS can scale to meet that demand. But likewise, they've managed things so that it can scale all the way down to zero too. So if there's no demand for whatever reason, like people just are toying around with their models that they just built, and so there isn't much activity, they can scale these instances, these EC2s, all the way down to zero, so that we're not being charged for it, which is great.
Yeah, that's a very exciting part of it for me because, especially the usage, and I know I haven't shared some of this data with you, but the usage pattern we see is a single user will come on, build a bunch of models, and then go away for a while, come back and do that all over again. So we do see that bursty sort of aspect, and we're anticipating more of that. So that, and especially the spin down, if no one's in use in the middle of the night, those made a great solution for us, I think.
Yeah, yeah, for sure. I mean, yeah, the instances get pretty big when you load these language models into memory. So having them on all the time could run up the bill pretty quickly. So yeah.
So cool. To wrap up, maybe let's run down the tool chain we used here and just comment on where they fit in the pipeline. So you'd already mentioned Jupyter. What role does it play?
Jupyter was great for the EDA side of things. Like when we were first looking at how the BERT pipeline was going to compare to a TF-IDF approach and visualizing the distribution of BERT vectors, things like that. Just the initial part of getting the project to work and to look at the initial data, Jupyter was great for that.
And I mean, Git goes without saying, and we've covered AWS Batch. How about Docker?
Yeah, so Docker was great for being able to reproduce the machine learning pipeline on my machine on demand, on your machine on demand, and then to have AWS host the process and for them to reproducibly begin the process in the cloud. So
Yeah, and what about storage? Where does everything live? Do we have metadata on the models?
for the model storage, it's all S3. And then for recording what happened during the model building process, both online and then once the model's built, we have individual records for each model building process in DynamoDB. That was great for development, actually, because we had a nice system for recording errors. Sometimes visibility is a little bit difficult when you're working in the cloud and trying to get things running in the cloud.
Wow, that's a whole other show, man.
Yeah. But short story, DynamoDB for all the record keeping.
For sure. And last but not least, Terraform.
Oh, yeah. Yeah. We didn't even talk about Terraform, but that's been a fantastic tool for managing all these serverless components.
I don't know if everyone will know what it is. Can you give a quick definition before how you used it?
It's kind of like Docker almost. So, Docker, you have these Docker files where you write out all the commands that you would need to run in order to build your operating system and the applications you need for running the process. Similarly, with Terraform, you've got these Terraform scripts, and inside are basically these big configuration files that specify the AWS component that, or it doesn't have to be AWS, it could be tons of.
Yeah, quick footnote on that. The whole show we've been talking about AWS, not because it's a commercial, but because that's what we happen to use. Pretty much all this we could have done anywhere. We're vendor agnostic. But anyway, sorry to interrupt.
Yeah, so it's you list out all the resources that you want to build in your cloud provider. You can run this Terraform script, and Terraform knows how to build that out in your cloud account. What's great is it can do that reproducibly. So I had this awesome experience where I worked really hard to get this Terraform configuration file ready for the machine learning pipeline, and I had it working on my development AWS account. But then we decided it was time to move it into production. And so I just sent you this Terraform script and the repo that we used for the pipeline and Docker file. Between those three things, you had it in the production system working in about an hour. And that was just, I think, the time it took to build out all the resources in the cloud and get them loaded. So it was just like this magical moment for me where I saw the power of the infrastructure. It's like the term is infrastructure as code. I saw the power of having it all written out in code at that moment. It was pretty cool.
Yeah, thanks to HashiCorp for helping change management engineers lose their jobs everywhere. No, but in all seriousness, it's standing on the shoulders of giants. That's a powerful tool.
Yeah, for sure.
Well, to close it out, Alex, you've been spending all this time building training models. Now that the project is pretty much complete, what are your thoughts on a good use case? What would you like to build for real this time using the tool you've built?
Oh, yeah. I haven't spent a ton of time thinking about this, but it would be fun to create a bot that kind of, to go back to the Reddit comment moderation, just the first thing that comes to mind is to build a bot that can automatically moderate message board channels. So it could be Reddit, it could be something else, but some kind of way to help manage and enforce the rules of a message board. I think that would be a lot of fun.
Very cool. Yeah, let's explore that and see what happens. Well, anyways, Alex, it's been a tremendous pleasure working with you on this project and many others. Thanks for coming on the show and sharing your experience.
Yeah, likewise, Kyle. It's been a pleasure. I expect there'll be many more adventures to come, and thanks for having me on.